Dog sledding. Potential energy. Kinetic energy.
How does physics apply? Inertia, the sled will be constantly moving against the snow at a constant speed in a straight line unless Newton's first law comes into play.
Constant speeds and acceleration. The dogs are going at a constant speed no matter how fast or slow they are moving. In this case, the dogs have a positive acceleration.
First law of motion. The sled stays in motion unless acted upon another force causing the sled to slow down.
Second law of motion. The force the dogs use to move the sled will be balanced out and the sled will be pulled with that same amount of force. The faster the dogs go, the faster the sled goes. The slower the dogs go, the slower the sled goes.
Third law of motion. The dogs pull the sled with a certain amount of force. The sled is pulled with the same amount of force.
Friction. Having a smooth dog sled will help pulling against the snow, smoothly improving speed and stability.
Conservation of energy. He when the dogs are waiting to pull the dog sled. Ke when the sled is in motion. Pe when the sled stops. There's no GPE because there's no gravitational chain. What equations can I use?
Friction. N equals force of friction divided by perpendicular force exerted by the surface on the object. F subscript 1 divided by Fn. Force of friction is equal to the force required to slide the object on the surface with constant speed. N is only valid for surfaces with any significant changes to surfaces, in this case the changes from fresh snow to wet and slushy snow. Conservation of energy. Work equals force applied in newtons times distance in meters. W equals F times D. In this case, the slack between the dogs and the sled is EPE equals half times K times X squared. K equals spring constant in newtons per meter. X equals amount of bending in meters. KE equals half times M times V squared. M equals mass in kg of moving object. V equals speed in meters per second of the object.
Second law of motion. Acceleration equals force divided by mass, or A equals F divided by M. Calculating speed and acceleration. The average speed equals distance traveled divided by time elapsed, or average velocity equals change in distance divided by change in time. Acceleration equals change in speed divided by time interval, or A equals change in velocity divided by change in time.
Projectiles and trajectories. Projectiles and trajectories are of no use in the dog sledding scenario since they are not trajectories.